My name is Hadi Farhangi on Basics of Statistics. The topic, Hypothesis Testing, One Population Mean. Topics to cover: first, distributions and basics of hypothesis testing, settings of hypothesis testing, confidence interval and p-values for hypothesis testing, hypothesis testing of one population mean and two-tail hypothesis testing, right-tail hypothesis testing, and left-tail hypothesis testing. Some useful distributions for hypothesis testing are standard normal and t-distributions. Calculating standard normal probabilities using Google Sheets, probability of z less than equal to x in Google Sheets is norm.dist inside parentheses x 0, 1, 1, separated by commas. Calculating probabilities of t-distributions using Google Sheets, probability of t less than equal to x with a degree of freedom of nu is t.dist x nu 1, separated by comma. Definitions in hypothesis testing. Hypothesis testing investigates the claims about variables. Such claims can be as follows. The mean of a variable is increased, decreased, or changed. The mean of a variable is greater, smaller, different than another variable. The variance of a variable is increased, decreased, or changed, etc. Definition. Hypothesis testing is a process to test a claim, and it concludes with either rejecting a claim or accepting it. Note that the claim is shown with HA or alternative hypothesis, and its logical opposite is shown with H0 or null hypothesis. In every hypothesis testing, one should state H0 and HA first, which dictates the setting and shows how to proceed with the testing. Hypothesis testing using confidence intervals. If the claim is true, then the parameter as stated in H0 should not belong to the confidence interval on the claim. So one should, step one, state the setting of hypothesis testing. Claim gives HA and its logical opposite gives H0. 2, construct the confidence interval for the parameter that is based on HA. Step 3, accept the claim, reject H0 if the interval and H0 do not intersect. It follows that one should reject the claim, fail to reject H0 if the interval and H0 do intersect. Hypothesis testing using p-values. The steps for hypothesis testing using p-values are: step 1 states the setting of the hypothesis testing. Claim gives HA and its logical opposite gives H0. 2, calculate p-value. It is the probability of being outside the confidence intervals. It depends on the distribution, type of the test, etc. Step 3, if p-value is less than alpha, then one should accept the claim or reject null hypothesis. Otherwise, reject the claim or fail to reject the null hypothesis. Hypothesis testing of one population mean. This section investigates the claim about the mean of a single population. These are 3 types of claims that are of interest. These claims are: 1, the mean of a variable is not a certain value. This is two-tailed test. 2, the mean of a variable is bigger than a certain value. It is right-tailed test. 3, the mean of a variable is smaller than a certain value, or left tail test. For the two tail test, this is the setting h0 mu equal to a certain value, ha mu is not a certain value. For the right tail, mu is greater. That's why it is called right tail. And logical opposite, mu less than equal certain value. For the left tail, mu less than a certain value. That is why it is left tail. And logical opposite, mu greater than equal a certain value. Hypothesis testing of one population mean two-tail test. The claim is that the mean of a variable is changed, or it is not a certain value. We saw that using confidence interval. These are the steps. Using the p-value, these are the steps we follow. The step 1 is the same in both methods, and it is h0 mu is certain value, ha mu is not a certain value. Step 2, to construct the confidence interval. If sigma is known, we use one formula as you can see on the video, and if sigma is unknown, we use t and s instead of z and sigma. And to calculate these confidence intervals, we have to know xn, the sample size, x bar, sample mean, 1 minus alpha, confidence level, sigma, population standard deviation, s, sample standard deviation, z alpha divided by 2, critical value of that, t, critical value of t, nu is n minus 1 degree of freedom. As for the p-value, the same setting for the hypothesis testing. But if sigma is known, p-value is calculated 2 times probability of z less than minus absolute value of x bar minus mu divided by sigma over a square root of n. And when sigma is unknown, 2 times probability of t less than that value. Instead of sigma, we use s. And the values, we don't use z alpha divided by 2 or t alpha divided by 2, only n, x bar, 1 minus alpha, sigma, or s, and degree of freedom, nu, equal n minus 1. And step 3, for the confidence interval, if they do not intersect, we accept the claim. For the case of p-value, if p-value is less than alpha, we accept the claim. Here's an example of two-tail test for population mean. A coffee shop constantly has an average number of weekly customers around 200 with a standard deviation of 10 customers. The manager, however, suspects the average number of customers is different than 200. He takes a sample of 36 weeks and the average is 250. Conduct a hypothesis testing to determine if the manager's suspicion is correct. Assume the confidence level is 90%. Answer. It is a good idea to summarize hypothesis testing questions as it makes it easier to answer. Here's the summary. Claim mean is different. The mean, you should use two-tail test on one population mean. Sigma is known to be 10, n 36, x bar 250, 1 minus alpha is 0.9, which means alpha is 0.1. Solution using confidence interval, and I will solve it again using p-value. Step 1 for confidence interval, claim is mu is not 200. This gives the following setting, which means the test is two-tail over the mean of one population. H0 mu 200, HA mu is not equal to 200. This is the setting of two-tail test. Step 2, the confidence interval for HA in case of two-tail is, this is the case, sigma is known to be 10. X bar minus z alpha divided by 2 times sigma over a square root of n as lower bound, and plus C alpha divided by 2 sigma over a square root of n as upper bound. Z alpha divided by 2 is z 0.1 divided by 2 z of 0.05, which is 1.645 using Google Sheet. The calculation for the confidence interval is, as you see over here, I put all these values that we summarized from the question inside this equation for the two-tail test when sigma is known. X bar is 250, Z alpha divided by 2, 1.645, sigma is 10, N is 36. I put everything inside, and the result is mu between 247 and 252. Compare this interval with H0, which is mu 200. It shows they do not intersect or overlap. This means one should accept the claim, which means the number of customers is different than 200. Now, solution based on using p-value. Step 1 is exactly the same as step 1 using confidence interval. That means H0 mu equal to 200, HA mu not equal to 200, which is the setting of two-tail test for population mean. Step 2, calculating p-value for this setting is as follows. In this case, sigma is known to be 10. P-value is 2 times probability of z less than minus absolute value of x bar minus mu over sigma over a square root of n. I know x bar, mu, sigma, and n. I substitute everything over there. I summarize everything. It will be 2 times probability of z less than minus 30, which is close to 0, which means p-value is close to 0. Comparing p-value equal to 0 with alpha 0.1 shows that the claim is accepted, or the null hypothesis is rejected. This means the number of customers is different than 200. Hypothesis testing of one population mean now right tail test. The claim is that the mean of a variable is greater than a certain value. I only show the steps for using p-values here. These are the steps. Step 1, the setting HA mu greater than certain value, exactly as the claim says. That's why it is right tail, and H0 mu less than equal a certain value. And for calculating p-value, it will be z greater, like HA, that is mu greater. Here it is z greater, x bar minus mu sigma over square root of n. And the case sigma is unknown, it will transfer to the t. And you need to know n, x bar, 1 minus alpha, sigma, s, and nu, degree of freedom, equal to n minus 1. And if p alpha is less than alpha, we accept the claim. Otherwise, we reject the claim. For the right tail test of one population mean, we saw these are the steps we have to follow. This is the setting, these are the calculation of p-value, and this is the condition to accept or reject. Here's an example. A doctor claims that he has more than 50 surgeries on average each week with the variance of 5. He considers the last 50 weeks and the average of surgeries is 55. This average makes him believe the average is bigger than 50. Conduct a hypothesis testing for this claim, assuming a 97.5% confidence level. Here's the answer. The summary of question is as follows. Claim mean is bigger than 50. This means you should use a right tail test on one population mean. Second, sigma is known to be 5 and 50, x bar 55, 1 minus alpha 0.975 and alpha 0.025. Step 1, the claim is mu greater than 50. This gives HA. Its logical opposite is that mu less than equal to 50. That means H0. And the setting is HA mu greater than 50, right tail test, and H0, the logical opposite, mu less than equal to 50. Step 2, calculate p-values for this setting. Now you know that sigma is known to be 5. P-value is probability of z greater than x bar minus mu over sigma over square root of n. And we know x bar, mu, sigma, and n. We plug in every value here. We summarize it. Then it will be probability of z greater than 7.707, which is the same as probability of z less than minus 7.07, which is 0. Comparing p-value equal to 0 with alpha 0.025 shows the claim is accepted or reject the null hypothesis. This means the average number of surgeries is more than 50. Still on the right tail test for one population mean all the steps are here. And we see another example that we solved the previous example if a x bar 51, b s equal to 5, and sigma is unknown while x bar is 55. The answer. The summary of previous example is as follows. Claim mean is bigger than 50. This means you should use right tail test on one population mean. Sigma is known to be 5 and 50. 1 minus alpha is given and alpha is 0.025. The step 1 for both part is that H0 mu less than equal to 50, HA mu greater than 50. Step 2, calculate p-value for part A. Now x bar is different, sigma is still 5, so instead of x bar 55, we use x bar 51. And we have all the values, we plug them in. It will be probability of z less than minus 1.414, which is 0.079. For part 3, to make a decision, we have to compare this p-value with alpha. P-value is 0.79 and alpha is 0.25. It is not. P-value is not less than alpha. So it shows that the claim is rejected, or we fail to reject the null hypothesis. This means the number of surgeries is not more than 50 in the case A. For the part B, calculating p-values for this setting is as follows. S is equal to 5 and sigma is unknown. So we have to use t distribution for a calculation. It will be probability of t greater than x bar minus mu s over a square root of n. We know x bar 55, mu 50, s5, and 50. If you summarize it, it will be probability of t less than minus 7.09 and degree of freedom 49. In this case, p-value is very close to 0. We consider it to be 0. Now that p-value is 0, it becomes less than alpha, which is 0.025. It shows the claim is now accepted. In the case B, we accept the claim. This means in this case, the number of surgeries is indeed more than 50. Hypothesis testing on one population mean left tail test. The claim is that the mean of a variable is less than a certain value. I only show the steps for using p-values. These are the steps we covered before. Here, HA mu less than a certain value, exactly as the claim says. As S0, the logical opposite, mu greater than equal a certain value. And here again, sigma is known or sigma is unknown, the formulation is different, and because the claim is mu less than a certain value, here z or t less than certain value. The certain value is x bar minus mu sigma over square root of n. For the case t, x bar minus mu s over a square root of n. And these are the same as before. We need to know n x bar 1 minus alpha sigma over or s and new degree of freedom. And step 3, if p-value is less than alpha, one should accept the claim or reject the null hypothesis. Still on the left tail test, I showed you the step mu less because the claim is about the mu is being less and calculation of p-value there or less. Example, assume the grade of a student has a mean of 80 and a standard deviation of 10. A professor suspects the mean of grades is less than 80. He takes a sample of 40 students and the mean of the sample is 78. Conduct a hypothesis testing to determine if the professor is right in his claim. Assume the confidence level is 99%. Answer. The summary of question is as follows. Claim mean is less than 80. This means you should use left tail test on one population mean. Sigma is known to be 10 and 40 x bar 78, 1 minus alpha 0.99, which means alpha is 0.01. Step 1, claim is that mu less than 80. This gives the following setting. That means the test is left tail and over the mean of one population. HA mu less than 80 based on the claim, H0 mu greater than equal 80 logical opposite. Step 2, calculating p-value for this setting is as follows. We know sigma is known to be 10, so we use z, and based on the formula for the left tail test, z less than x bar minus mu sigma over square root of n. That is the probability we are calculating. We know all these values, we plug in, it will be probability of z less than minus 1.264, which is 0.103. Comparing p-value equal to 0.103 with the alpha 0.01, it is not less than alpha, shows the claim is rejected. This means the average is not less than 80. Still on left tail test, in the previous example, test the claim if x bar is 81, b sigma is unknown, and s equal to 4. The answer. Pause the video and solve it yourself. Answers are going to be in the notes.